Namaste to all my dear residents. How are you? Again, I am talking about the comparative study on preparation and important chemical properties of chlorine, bromine, and iodine, because chlorine, bromine, iodine are only asked in examination. So the topic is like this: comparative studies on preparation and important chemical properties of halogens. Yes. So first one is comparative preparation on preparation of chlorine, bromine, iodine. Yes. So first one is lab preparation. Lab preparation of chlorine. So I have already told you they have similar general preparations. What do you have? So first one is lab preparation of chlorine. Preparation of chlorine with application of heat. Application of heat means only in presence of heat we can prepare by chlorine gas. So what we see, NaCl, sodium chloride, manganese dioxide, conch, sulfuric acid when heated. So what to get? NaH, sodium, hydrogen sulfate plus what to see, manganese sulfate plus H2O plus Cl2. So what we have? 2NaCl, 3H2SO4. Yes. So lab preparation of chlorine with application of heat. So that is the sign of the heat. Lab preparation chlorine without application of heat. So what you see in this case, two methods. So from manganese dioxide. So what we see, when manganese dioxide when reacted with conch hydrochloric acid, so what to get? Manganese chloride H2O plus Cl2, that is manganese dichloride. Yes. So balance is like this: 4HCl, 4 and -2H2O. Yes, that is the balance chemical equation. Next one is what is the second? From potassium permanganate. Yes. So formula of potassium permanganate is KMnO4 when treated with conc hydrochloric acid. So what to get? KCl MnCl2 plus H2O plus Cl2. Yes. So after balancing what we have? 2, that is potassium permanganate. Potassium 16 HCl 16 conc HCl 2 KCl 2 MnCl2 8 H2O and what to see? 5 Cl2. Yes. So we can prepare lab chlorine gas in the lab. 2 method. First one is by application of heat, NaCl MnO2 plus conc sulfuric acid. Next one is without application of heat. So 2 compounds we can use over here. One is manganese dioxide that react with conc HCl and what we get? Manganese chloride, water and Cl2. Likewise, when we talk about the potassium permanganate, when that is treated with conc HCl, so what we have? Potassium chloride, manganese chloride, water plus Cl2. Yes, 2 methods over here. Yes, so that is the lab preparation of chlorine. Now, second, lab preparation of what you see? Bromine. So bromine, what we can use over here? So what you see? NaBr, sodium bromide, and that is heated with manganese dioxide, conc sulfuric acid. When heated, what we have? Potassium bisulfate plus H2O MnSO4 plus H2O and Br2 as a distillate. Distillate means, when distillate means when liquid is heated, change the vapor and vapor is condensed, what we get? Liquid again. So that is known as distillate. So after balancing what we have? 3, so what we get? 2. Sorry, sodium over here. So we can write over here. We can write sodium. If potassium, we can use potassium. Yes. It's lab preparation of bromine. Third one is lab preparation of iodine. So what we see? What we can use? Sodium iodide. When heated with manganese dioxide, conc sulfuric acid. So what we have? Sodium bisulfate, manganese sulfate plus water plus iodine. That is solid. What is it? Sublimate. Sublimate, when solid is heated, change the vapor and vapor is cool, what we get? Solid again without any change in its chemical composition is known as sublimate, and compound is known as sublimate. Yes. So I see 2 NaI, or see 3 sulfuric acid, 2 sodium, that is the sodium bisulfate, better to say hydrogen sulfate. Yes, so we have cleared, I think. So that is the comparative lab preparation of what to say, comparative lab preparation of what to say, chlorine and bromine. Now next heading is comparative. I better to SB, you can say comparative chemical properties of chlorine, bromine, iodine. Yes, so only chlorine, bromine, iodine is asked examination, not fluorine. So what do you see? First one, what do you see? Reaction with alkali. So we can use maybe sodium hydroxide, maybe potassium hydroxide. Alkali means those bases which dissolve in water and give hydroxide ion, that is known as alkali, you know. So in this case, two conditions over here. A, with cold and dilute. Dilute means low concentration. Dilute sodium hydroxide, we can use potassium hydroxide over here. Sodium hydroxide. So what do you get over here? Sodium hydroxide plus chlorine. Condition in this case is, what is it? Cold and dilute. So what do you get? Sodium chloride, sodium hypochlorite, that is known as sodium hypochlorite. Yes. So balance is balance with sodium NaOH. So what we have? 2 NaOH. Yes. So 2 NaOH that is already right side, already balanced. Second, with hot and conc. Conc means concentrated sodium hydroxide solutions. So what we have? Cl2 sodium hydroxide, condition is hot and conc. Conc means concentrated. So what we have? Sodium chloride is common. Next one is sodium chlorate plus water. Yes, so balance is like this. So what do you see? 6 NaOH, 6 NaOH, and what do you see? 3 Cl2 in right hand side, sodium chlorate. What do you see? 5 NaCl, and what do you get? 3H2O. Yes. So you have to remember the products, not the what's the balancing. We have to do the balance. Sometimes what is it and trial method. Sometimes we have to balance by partial method. I have already taught you. Yes. So the reaction with alkali. So what do you see? Reaction with alkali with cold and dilute sodium hydroxide. So what to get? Bromine. Bromine also gives reaction similar to chlorine. So, yes. So in this case, we have to change after bromine. So what to get? Sodium bromide, sodium hypobromate. So one is like this. What to say? Sodium hydroxide, bromine. Condition is what to say? Cold and dilute. So what to get? Sodium bromide, BrO plus H2O. That is sodium hypobromite. Yes. So balance is like this. NaCl 2NOH. Yes. So right hand side is already balanced. That is cold condition. Next one is with hot. With what you see? Hot and concentrated sodium hydroxide solutions. Only what we have to do? 3Br2 plus 6NaOH. Yes. So what is the condition is over here? Is what you see? Hot and conks. What we have? Sodium bromide plus sodium bromate plus, that is sodium bromate, that is sodium bromide. Yes. So balancing is like this. So 6Cl2, 6NOH, right hand side 5 sodium bromide and 3 H2. Yes. So similar reaction. Third one is with iodine. So what we see? A, dilute and cold sodium hydroxide solutions. What we have? Sodium hydroxide plus iodine. Condition is dilute and cold. So what we have? Na, sodium iodide, HiO, that is known as hypoiodous. It's already balanced, I think. That is already balanced. A, B, what is the with hot and concentrated sodium hydroxide solution. So reaction is like this. So what to say? Same reaction. NaOH plus I2. Condition is hot and conks. So what we have? Sodium iodide, sodium iodate plus, that is sodium iodate. So after balancing, so what we have? So bromine 3, so 3 iodine, NaOH 6 NaOH, 5, and what is it? 3H2O. Yes. So what to say? With alkali solution. With next one is second, with ammonia. two conditions over here. What do you say? Excess ammonia and less chlorine. So what we have? Generally asked, very important. So what you see? Ammonia excess plus what you see? Chlorine less. So what we have? Ammonium chloride plus what you see? Nitrogen. That is ammonium chloride. Yes, so balancing up to see what to get. Ammonia 8NH3 and what to say? 8NH3 3Cl2 836 6 ammonium chloride, like this. The NH3Br2 same reaction, excess less. So what we have? 6 ammonium bromide plus what is it? Ammonium bromide. Yes, so what is it with ammonia? A, excess of nitrogen, A condition. Now the B condition is like this. B, what do you say? Excess chlorine and less ammonia. So what we have? So what do you see? Excess, what do you say? Chlorine is excess plus what do you say? And ammonia is less. In this case, what we get? Nitrogen trichloride plus HCl. That is nitrogen trichloride. Yes, so balancing is, so what is balance? 3Cl2, so what to get? 3HCl balance. Likewise with bromine excess ammonia less. So what we have? Nitrogen tribromide plus HBr, that is nitrogen tribromide, that is hydrogen bromide. Yes, so what we have to do? 3HCl. So excess chlorine and less, but with next one with iodine. It gives only black precipitate nitrogen triiodide and hydrogen iodide. So reaction is like this. Any condition, maybe low iodine excess, does not depend. Iodine plus ammonia in all condition what is this? What you get? Nitrogen triiodide, black PPT, nitrogen triiodide plus what you see? Hydrogen iodide, 3HIS. So the second one is comparative chemical properties of first chlorine, bromine and iodine. Now with ammonia. Yes. So in chlorine bromine same reaction. In excess what we get? Excess ammonium chloride and nitrogen. With less what we get? Nitrogen trichloride and HCl. Yes. Comparative study, that is very important and generally asked in examination. So third one is what is the bleaching properties. Bleaching properties of halogens. Bleaching means bleaching properties. So decolorization, to change one color to decolorization of chlorine material, decolorization of chlorine material in presence of moisture is known as bleaching properties. So look at with chlorine, so at first chlorine reacts with water and what we get? HClO plus HCl. Now that is hypochlorous acid, that is unstable, and convert into HCl plus nascent oxygen. Now this nascent oxygen with chlorine material, what do you get? Decolorized materials. In this case we have to remember I've already talked in what is SO2 also. So in this case we have to remember like this. So here bleaching properties takes place due to oxidation. Yes. Here bleaching properties is permanent. Yes, permanent means never come in original position. Third one is bleaching properties is stronger than bromine sulfur dioxide. Yes. So that is about what to say bromine, what is it? Chlorine. 3 points we have to remember over here. So here bleaching properties takes place due to oxidation. Here what to see bleaching properties is permanent. So we cannot reconverted into the original position. Its bleaching properties is stronger than bromine and SO2. I have already talked in SO2. Yes. Bromine has somewhat lower. So what is the bromine with bromine? Bromine, yes. Bromine again react with water, and what to get? HBrO plus HBr. HBr hypobromous. Yes, it's an unstable compound and decompose into HBr plus nascent oxygen. That nascent oxygen decolorizing material, what you get? Decolorized material. Yes, in this case we have to remember here bleaching properties is due to oxidation. These are the main point. Oxidation. Yes. Here bleaching properties is permanent like chlorine. Third, its bleaching properties is weaker than chlorine, but stronger than what you see sulfur dioxide gas. Yes, these are the things we have to remember when you talk about the bleaching properties of what you see bromine. Yes, here bleaching property is due to oxidation. Here bleaching property is permanent. Third one is bleaching properties is weaker than chlorine, but what is stronger than SO2, sulfur dioxide gas. Yes. Third, iodine. Iodine does not show what is the bleaching properties. So yes, we have clear. So chlorine, bromine gives bleaching properties, but iodine does not show bleaching properties. Yes. Next one is fourth test for halogens with silver. I have already told you in what is the organic chemistry, silver nitrate solutions. What we have? What is the NaCl? Suppose original solution. What do you mean by original? Solution made from the sodium original solution. When added silver nitrate, solution that is colorless. So what we have, AgCl plus what we see, sodium nitrates. What type of PPT? White curdy precipitation over here. Yes, like this when we talk about sodium bromide, that is the original OS, original solution, when treated with silver nitrate solution. So what to get? Silver bromide plus, so that is pale yellow PPT. Yes, PPT means precipitation. Likewise, sodium iodide original solution when treated with silver nitrate solutions. What we have? Silver iodide. Silver iodide plus what we get? So what type of PPT? Deep yellow PPT. Deep yellow PPT. Yes. So first case what you get? White curdy, similar to curdy precipitate. AgBr what you get? Pale yellow PPT. But when talk about the silver iodide, so what you see? Silver iodide, that is deep yellow PPT. So already we can clearly compare. What you see? We can do the separate the what you see, chloride, bromide, and iodide present in the solution. Yes. These are the comparative. Next one is other important chemical properties of iodine. Yes. So first one is with sodium thiosulfate solutions. What we have? Na2 sodium thiosulfate plus iodine. What we get? Na2S4O6 plus, that is sodium tetra thionate. After balancing, what we have? So after balancing we get 2 sodium thiosulfate to 2 sodium iodide. Yes. Second one is reaction with KClO3, KBrO3 separately. So what we see over here? KClO3, that is potassium chlorate. When that is treated with iodine, so I do substitute this chlorine. What we get? KiO3 plus what you see? It displaces the chlorine over here. That is potassium iodate. Yes. Likewise, KBrO3, potassium bromate plus iodine. So what we have? Potassium iodate plus Br2. So what you see? 2KClO3, 2KIO3, 2BrO3, 2 yes, that is substitution by what is iodine. So these are the main important chemical properties of halogens, chlorine, bromine and iodines. So thank you for watching this interesting video. So have a nice day. Be bona fide in chemistry like Silakansa. Thank you. I think you have already subscribed it, and also convey your friends for learning. Yes. So thank you all.